All right, so in this example here, we're looking at rotation and torque and force. So it says a cue stick strikes a cue ball horizontally at a point a distance d above the center of the ball. It's asking us to find the value of that d in terms of r, because that's what we can think about for a ball here, in which the cue ball will roll without slipping from the very beginning. So there's some different pieces here. One of the things I want to talk about is this idea, because it's hitting horizontally, we can go ahead and just assume perpendicular. We don't need to worry about any angles in which the force is coming in. We can just assume this perfectly horizontal or perfectly perpendicular relationship. It does tell us that we are d distance above the center of the ball. So I tried to kind of draw a diagram here for us. So this is going to represent my cue ball here. I know that I have some R out to the side or down or to the side or up, and we're actually going to see what that looks like in a second. I just sketched in some D because we don't know what it is. That's what we're trying to find. And my cue stick is coming here and hitting the ball in this way. So because it's asking us about the the cue ball will roll without slipping. The stipulation that goes with rolling without slipping has to do with the velocity and acceleration of the center of mass of the ball, and how it relates to the rotation to it. So we can say that because we know that it's rolling without slipping, that the velocity of the center of mass is going to be equal to r omega, as well as the acceleration of the center of mass is going to be equal to r alpha, where omega and alpha represent the angular velocity and the angular acceleration. So these are the stipulations that I'm going to be using in solving this problem. Because I have something that is both rotating and it's going to be moving translationally, I'm going to set up a sum of torques and a sum of forces. Now, I only have one force acting here, and it's that on the cue stick, because that's what we're dealing with. We know that there might be some friction to cause the rotation itself, but here we're really just analyzing this cue stick, so that's what we're going to look at here. We're going to start with that, and we know that our force of the cue stick is simply going to be equal to ma. For my torques, well, once again, we're looking at analyzing this one. We know that in general, torque is equal to I alpha, where I is our rotational inertia or moment of inertia. And this is also equal to F R sine theta. Now here, you might want to jump in and use this R. But when we're saying FR sine theta, we're really talking about the distance away from the axis of rotation that your force is hitting. And we're talking about that perpendicular distance. So since it's coming in perfectly horizontal, my axis of rotation is here. We are looking at this distance here, which is the D. It's what we're trying to solve for. So it's actually going to be FD. And because we're looking at just that perpendicular distance, that is that sine of theta. We don't need to include that. Now I'm going to assume that my cue ball is uniform solid sphere, and its moment of inertia is 2/5 mr squared. Because we're looking at this non-slippage relationship, instead of writing alpha, I'm going to use this over here, and alpha is equal to A over R. F, we see from over here, is equal to MA, and then D is D. And here we are trying to solve for D in terms of R, so we're hoping that we can get rid of some of this other stuff. I now see that I have M on both sides, so that's going to cancel out. I have an A on both sides, so those will cancel out. I have an R in the denominator and an R on the top, so that cancels out, leaving me with 2/5 R is equal to D. At this point, I've actually solved it out. That's what I was looking for. If I wanted to go back into my problem and see what that actually looks like, so once again, if this whole distance is R, it's just saying 2/5 of that, which is slightly less than half, so maybe here. So actually, this would be my distance, and my cue ball would be, or my cue stick would be here. So it's not that far away from the center at all. It's just 2/5. So between the center of mass and the top of the ball, so the radius there, and we're looking at that perpendicular distance.